Okay, 8th graders, I'm going to get you started on a new activity. This is something I have never done with Burlington Middle School students. I was able to do this with some students at West Burlington. In the past, we were kind of limited on time and materials, but now we have the trimester with some extra weeks, and we have a lot of new VEX equipment that we can work with. So I'm going to be giving you a series of tasks over the next 2.5 weeks where you have to actually create these yourselves, which means no two group projects should look alike. This should be original work. You can get as creative as you like as long as we're respecting the materials that we are using. You're going to use some VEX pieces. If you want to add a little artwork with some paper or printing off some images, that's fine as well. So it's kind of like when you were working on the windmill or the pull toy. This was your creation, your design, something you were going to build yourself. What's different in this scenario is you're going to have to add a motor, you're going to have to add at least one sensor, and in some instances you might be adding more than one sensor. So your first task is going to be called the spinning sign. So it's going to give you a hypothetical situation. The mission for the spinning sign is as follows. A marketing firm has determined that more customers will enter a shop if the sign is neat and eye-appealing. To increase business, you decide to design and build a spinning sign with a catchy title for outside your shop. To conserve energy, you must install a stop switch for the sign when the business is closed. This stop system should be able to be engaged by a person on the ground away from the sign. So as you're kind of envisioning this, I see maybe you're using one of those motors like you had on your drive wheels for your Clawbot. It might have to be pointed up in the vertical position. You might have a long supported drive shaft. It could be something like if you did the windmill with the bevel gear, you might have something that goes straight up. As a bonus to this, you could add a second switch to turn the sign back on. So many of you are working in groups of 2 to 3 people. What you should do here is really split up the work. Someone should be a mechanical engineer. As a mechanical engineer, you must decide what the design of the mechanism is going to be. I'm not going to ask you to sketch your solution, but this is something that Project Lead the Way suggests, and if this helps you, that is fine. However, as the mechanical engineer, you're probably the one that needs to seek out what parts you need for the VEX kit. Maybe you need a base plate. Maybe you need to set up another girder, or at the very least, you have to decide how you're going to support the motor so that it is in the upright position, so that a vertical pole or a vertical drive shaft would come out of it that would support the sign. As the electrical engineer, you're the one that kind of needs to decide where things are going to be plugged into the cortex. Now this sounds like maybe it's an easy task, but from experience we have seen that some of the problems that we found with the Clawbots were that we weren't taking the time to decide where we need to plug everything in. Remember, motors go in motor ports, digital switches go in the digital port, and analog switches go in the analog port. Also, as the electrical engineer, remember ports 1 and 10 for motors do not require a motor sensor, but ports 2 through 9 do. And you've seen this on the Clawbot, so you have to decide what port you're using. For the spinning sign, I really only see you using one motor, so you probably only need to use ports 1 and 10, and you're probably using 2 digital switches, so you're probably looking at digital ports 1 and 2. The computer engineer is the person that needs to do the programming. Think back when you started your test bed activity and you pushed a digital switch and you had one motor start. This is kind of the code that you're going to be working with the spinning sign. So the computer engineer, while the other engineers are busy working, you must write a program that will control the sign. The program should cause the sign to rotate when the program is started and stop the rotation when the switch is pressed. Don't forget that the purpose of the sign is for people to read it. If the sign rotates too quickly, it will be difficult for potential customers to read it. I'm not going to be sending you any template because I'm going to give you a printout of this document. Also, I'm not looking for any paperwork to be turned in like Project Lead the Way is suggesting. You simply just need to demonstrate your spinning sign to me and get it checked off. So, hopefully this activity of the spinning sign is a great way to get started building your own VEX equipment and writing your own programs. Up until then, you've been prescribed the mechanisms that you're programming, but your programming background by now should be thorough enough that this programming for the artifacts that you're creating is rather simplistic. So, good luck with this project.